Well, good evening, everyone, and welcome to Environmental Coffee House. Jennifer, Eliot, it is my pleasure to be hosting both of you. It's actually really exciting. Thank you for being with us. We have a full house out in the chat. People are joining us, and we've got a very newsy show. We're talking about gas tonight, and not that kind.
I was
Uh,
wondering how long it would take, Sandy.
it took me no time at all. I love the sound
Oh,
effects. So, anyway, here we are. Now, I'm just going to warn you it is pouring rain here. I don't know if the thunder and lightning's going to hit my house, but I have a backup battery. So, if the power goes out for any reason, we will not lose the show. Yay! All right. So, take it away.
All
it
right.
is great to see you tonight, Elliot. I haven't talked to you in several months. So, how have you been?
Well, I managed to splash all over Twitter that I had shingles, and I just want to let the world know that it's the world's most mild case of shingles, for which I am
God.
very grateful. I have one
Mm.
more day of antivirals to go, and I should be. I mean, those knock you out. So after that's over, I should be
All
okay.
right.
But yeah, no, it's been an adventure, and definitely is something you don't want to get if you can avoid it.
Oh,
But
no.
and Sandy, how are you? How's your
Sciatic
sciatic?
my sciatic nerve that's making my life miserable and I have to go away next week. It's lessening, going away, but I don't know, it was like weird. After my Tuesday night show, I got up, I walked around and all of a sudden, boom. I have no idea how it
Mm.
happened, what had happened. I mean, I've been doing, a lot of work outside and all that, but I was fine for my show. So how I had it happen? I don't know. I couldn't sleep for 2 days. But anyway, I'm here. We're here. And that's good. And Jennifer, I'm sure you're feeling great.
Actually, I am feeling great.
Yay!
I don't have any dread diseases at the moment.
One out of
I have recovered from the post-vacation sickness, which seems, obligatory for some reason. So yes, I'm quite healthy.
it's the times we
Thank you
live
very
in.
much.
I know I'm
Yes.
going away, but I will be fully masked, at least on flying, because I'm going to be with my 90-year-old mother and, got to take precautions for her.
Mm.
Yep. Okay. So, who wants to dive into the topic tonight? The
Well, Elliot, you are the guest. Where do you
the
want to start?
the GHGs.
Let's just go right for it. Let's do the topic of the day and see how long that takes, but make sure we get it in and
Okay.
cover this. And the topic is going to be CO2 equivalent, right?
Yep.
CO2 what
Mhm.
where are we? I guess the question is, what does that mean, CO2 equivalent, and where are we right now today? What is that number,
And
whatever that is,
that's all the greenhouse gases combined to give
right?
you one measurement. Okay, you're ready for the slides?
Sure, why not? Go for it.
Okay, we'll start out with the first one right here.
So I saw this and I was like, what is this mean and how can I reproduce it? And I was interested in that line, CO2 equivalent equals 523 parts per million, because that seemed like a really specific number, right? And just to make sure everybody's on the same page here, when you look at this, you notice that refers to CO2 and non CO2 greenhouse gases. So those would be methane and nitrous oxide and all of the fluorinated hydrocarbons, right? So all of the stuff we use for refrigerants and that kind of stuff. So that's what that is. That's all the gases that go into that. And I want to just show you this graph. If you look on the year part of it, you see how it starts at 1700 and then 1750, and nothing goes anywhere, right? They're all sort of at the same place.
Mhm.
Yeah.
That is the
Yeah.
baseline. After 1750, things started to happen, but not before. So
Mhm.
1750, what did we have? We had about 280, maybe a little bit less parts per million of CO2, right? And we had however much methane we had, maybe about 700 or 800, somewhere in that range of parts per billion, right? And we had whatever nitrous oxide, but those simply that they were at their baseline level. All these gases were at their baseline level. And then what's happened since then? Well, CO2 has gone up, right, from 280 to 425 or wherever it is today, right? Methane has gone up to about 1930, and nitrous oxide has also gone up. So the thing is, we have the total amount of CO2. That counts towards our CO2 equivalent. But how much methane do we count towards that? We should only count the amount that we've gained since 1750. We don't count the original amount because that was built into our baseline already, right? We don't want to double count stuff. So we're only going to count the methane that's accumulated since 1750. We're only going to count the nitrous oxide that's accumulated since 1750. And none of these other greenhouse gases even existed in the atmosphere.
Yeah, like perfluorocarbons. Yeah,
better than, I mean, that just essentially didn't exist. So when you look at this thing, you want to understand we have this baseline of 1750. It's the total amount of CO2 plus all of these other gases, what they have gained since 1750, right? And that's how we're going to get that number. And it's really important when you look at this to sort of understand that. And they have this line that looks like they've got some data somewhere and used some software and some equations and some numbers and added it all together and got 523. And I'm like, where did that come from? Right?
Where?
So I'm clicking on this and, I find all their data for every greenhouse gas for every year and everything like that. And they've got all these things in there. And then they just put down a number at the end. And you click on that number and there's nothing that happens. It doesn't tell you a formula. It doesn't tell you where. They calculate just like blop. There's a number, right? So I contact the guy who writes this table, right? And I ask him the question, how did you do this, right? I'm emailing him, right? He's at NASA or NOAA, right? No response. Then I asked, I went to their corporate hierarchy and I sent emails to the two people who I thought might be in charge of this division.
Yep.
No response. So then I write to Gavin Schmidt, right? I think he must know this. And he doesn't know how they came up with that number, but he knows the methodology they used.
Okay. That's good. Somebody does.
So I used Gavin's methodology and tried to reproduce this and failed. I mean, I just
Oh, wow.
Now, I failed because I didn't have all the baselines and all of the data I needed, but I came close enough that I felt pretty good about it. So I don't know. I'm ready to go to the next slide unless you have a question about this.
Anybody have a question? If you do, put a Q and I'll try to get them at the end, but make sure you put a Q so I can see it because the chat goes fast and I forgot to slow it down. I'm sorry. Okay, let's move on to the next one. Here we go.
So I posted on Twitter. I said, does anybody know how to do this computation, right? And one of the very famous doomers on Twitter who shall go nameless, posted this particular image.
Wow.
And this image comes up with at least 560 for the CO2e. And this is by a Professor Andrew Glickson. And I'm looking at this thing.
I like him.
And it's just wrong. It's wrong. It's wrong. Everything about it is wrong, right? It's got at least 3 major errors.
Wow.
All right. The first error is that it doesn't use any sort of baseline values at all, right? It doesn't use 1750. If you look at that sort of CH4 there,
yep,
right? They just multiply that entire value by this thing called the global warming potential. And we're going to get into what the global warming potential is in due time. But essentially, the global warming potential says if you have a ton of methane, what is that equivalent to in terms of CO2? It's about 28 tons of CO2 over 100 years or 80 tons of CO2 over 20 years, right? It's got these numbers. But he just multiplies the whole thing by 25, as if this CO2e should be some number that's about a 100-year period. That says something about 100 years, because that's what that 25 is for down there at the bottom, right? That 25 refers to the global warming potential over 100 years. It's nonsense. I mean, you just don't. The other thing he does that's wrong is that the conversion is based on mass. So a ton of methane is 28 tons of CO2.
Right.
Right? It doesn't say that 1,000 parts per million of methane is 28,000 parts per million of CO2. It's a weight conversion. You have to figure out how much that methane weighs in order to convert it to CO2. You just can't convert the number of parts per billion, right? Which is what he does.
Okay, and this is all these gases then have to have the same treatment to come out.
Yeah, and the third error is he doesn't have any baseline values in here, right? So he doesn't do a weight equivalent. He doesn't do a baseline value, and it's just, my head is just like swimming. How wrong can you get, right, with the calculation? He comes up with 560. Well, he could have done it over 20 years, in which case that 25 number would have been much, much larger and come up with like 700 for the CO2 equivalent. I mean, it'd be crazy. But the reason this is wrong, the reason you know this for sure is wrong, is look at that nitrous oxide. He said the nitrous oxide's 99 parts per million of CO2 equivalent, and the CH4 is 46 parts per million equivalent.
Yep.
By his argument, he's saying that nitrous oxide is twice as powerful as a GHG as methane. And every kid in grade school, right? You walk down the street and you ask someone who's a total stranger, what's the second, greatest greenhouse gas, right? They're not going to be saying, oh, it's nitrous oxide.
No,
No,
and that's
no way.
it's number 3 on the list I was looking at.
Oh, yeah, it's actually further down than
It
that.
is further? Okay.
Ozone is, but at any rate, so there's all these errors in this, and I'm like that's crazy. I've got to be able to figure this stuff out. So I go through all this math. I write this paper. I do all of these spreadsheet calculations, converting weights of this molecule to that, starting with the right baseline values for this and that. And when I add it all together, absolutely doing it the right way, the Gavin Schmidt way, using these global warming potentials in the right way, I come up with like 495.
Okay.
Like,
It's still
it's supposed to be 523, and I'm like 495.
Oh my goodness, that's a pretty big difference. I'm
It
surprised
is.
they made all these errors and
It's
that
a
they're
big
just
difference.
baked in, and no one has questioned it except for you.
I know. I couldn't believe it. I was like I look at this and it's total nonsense. It's top. I can't. Well, this is actually published. You can find this. You look up Andrew Blixen. You find this, and people are quoting this as if it's some
Gospel.
Bible verse, and it's just wrong.
Wow. Try explaining this on CNN, Eliot.
So, at any rate, show the next slide
Yes,
so people can be impressed with my spreadsheet.
Okay, wait. Shut that one off. And shut this one off. And this one. And it's this one. Sorry.
Right.
Okay.
So this is
I'm
my
gone.
spreadsheet calculation, and you
I'll get
see
you
it
back.
only.
No, I'll get you back. I don't know.
It
what
only
happened.
includes CO2, CH4, and nitrous oxide. And you see that those together, we get 216
Oh, yeah.
and added to the baseline of 425 and so on. So, it's one of these things where, if I had thrown in all of the gases, I might have gotten to their 523 number, but I didn't have access to all the data. This is all the data I had. So maybe if I had all the data, I could have matched them. So at any rate, I post this, and I'm very proud posting this, right? I'm very happy, proud of myself that I've done this computation. And feeling like, well, if I had all the data, I probably would have matched them. And along comes a rather famous YouTube personality, Twitter personality, Leon Simons, right? who says, "Oh, Elliot, you've done it completely wrong. Nobody does it this way. You are completely and totally wrong."
My
And
gosh.
No.
show the next slide.
Okay. I want to make sure I don't shut anybody off. Jennifer.
All right.
Okay.
So is this too technical, or are we doing this about?
No,
No,
this is
our
good.
audience loves this shit. Are you kidding? They wait for this because
They do.
they get sick of me
All
with
right.
my non-technical shows.
Yeah. By the way, it's 105 here in Santa Barbara, so I've got to
Wow.
cooling off.
105 there and torrentially raining
Wow.
here. What's it doing at your house, Jen?
It's perfect.
She has nothing wrong with her, and it's
There's
perfect. And we've
it's
got
perfect.
shit weather, both me and Elliot, and we don't feel good. But we're here. We're here. Yeah.
So this is straight from Copernicus. Who are some of my favorite people on the planet for climate stuff.
Per Copernicus.
And essentially, what they do is they have what's called the radiative forcing. And
Yep.
what that tells you is essentially how much heat the greenhouse gases are trapping on the planet.
All right.
And you notice that they say, for example, carbon dioxide, somewhere, if you look to the right, is somewhere around 2.28 watts per square meter. Well, 2.28 watts per square meter is probably about equivalent to 1.3 million Hiroshima bombs per day on the planet, worth of heating. So
Wow.
I mean, that is,
Wow.
that's like putting a light bulb. That's a 2-watt light bulb every, square meter and all over the planet. And you can see, if you add CH4 and N2O and all the halogens, which are the other greenhouse gases that are measured, you get this other, addition to that.
Right.
So those top two bars, those are the things that humans emit. All right. So humans emit CO2, CH4, nitrous oxide, all the halogens. We don't emit ozone. Ozone is a byproduct of
Mm-hmm.
the other emissions, right? It's created from this other stuff. We
Okay.
don't emit the water vapor. That's because we're heating up the planet, and the hotter the planet is because of CO2, the more water vapor. So we don't count those, right? On the other hand, there are these aerosols,
Mm.
right? And the aerosols you see on that
Mm-hmm.
blue bar at the bottom pushes the other way. So you add all this stuff on top and all the stuff on the bottom, and what you get down at the very bottom then is roughly where we are today. And where we are today is about 2.79 watts per square meter. So I was listening to a show on another YouTube station. I heard Leon Simons make the comment that 4 watts per square meter was equivalent to doubling CO2.
Okay.
So, hey, CO2 equivalent, right? If
Right.
4 watts per square meter is equal to doubling CO2, and 0 watts per square meter is just CO2, right? Then that's another way to do this calculation. And so I went online, I did my research, and I actually came up with the fact that it isn't 4 watts per square meter. It's actually 3.71 watts per square meter is equivalent to, doubling the CO2. And when I did all of that, and I did the math, and I came up with this formula. It had logarithms in it, and it was all a big, long formula. And I applied it to this data. I came up with 434 parts per, I'm sorry, did I say 430? 534
Right.
parts per million. All right? CO2.
Yeah. Wasn't
Now,
that in the first graph?
you want to
I
go
think it
back?
was
I just showed you this. Go back.
526.
This
Wasn't
is
it
really
See,
interesting.
523.
523? Okay.
523, that's 2022.
Oh, that's 20. Oh, so like we're even screwed more.
So this is
Yeah.
2023, and I came up with 534,
Okay. All
Uh-huh.
right.
right?
Right.
So you see, my number is probably correct
So, given this,
because
Elliot,
we're gaining.
right, but given this, is there a way then the layperson can understand that this is not going to, it's not going to magically go down?
Mm.
because we're not stopping any of it. All of these gases are being contributing to the equation, so to speak.
Yeah, and the one that you actually can read about right now is it was just in the paper today is ozone. Now, ozone has
Making
the sort of high level ozone hole over Antarctica, which is one thing. But then there's what's called tropospheric ozone. And
okay.
that's the ozone that actually heats the planet. And
Ooh.
it is a if you look at it, you would actually notice it has the second largest bar after methane, right?
Oh.
Um, we have CO2,
Oh.
then methane, then
Yeah.
ozone, and then all the halogens, and then nitrous oxide,
Wow.
right? As far as the size of
Yeah.
the stars.
Yes. Yes.
So the problem is this ozone is really hard to keep track of because it kind of doesn't exist for very long, and it's a result of certain processes in the atmosphere that can happen and then go away, and we don't really understand where it's coming from, and it's regional. So there's this huge effort right now to try and figure out ozone. But for the purposes of this one
Again.
number, CO2e, we cannot include ozone and we cannot include water vapor because CO2e refers to gases we are emitting, right? The
Right.
title of your show.
Right.
It's
We're not
what we're
emitting water vapor. Right.
right. We're not emitting. These are chemical reactions, right? And it all comes down to, I mean, the big point here is this number that you've probably heard about over and over again, which is the equilibrium climate sensitivity, the ECS. And what that number is, if you double the CO2, then it is how much will the planet warm? You double the CO2, how much will the planet warm? So double the CO2, well, CO2e is almost double. We started at 280, we're at 534 now, whatever.
Yeah.
So when we double that, well, all of the climate scientists, Michael Mann and Housefather and all those people, right, are like, oh, ECS is 3C or 2.5C, or right. And then along comes Hansen and says, no, it's 4.8, right. And then you might have seen a paper in the news just in the last week that said, no, it's really 10.
That's yeah. Well, that seems a little
Yeah, yeah,
fantastical,
yeah.
but yet does that create skepticism amongst people that are trying to say, okay, what's the bottom line here when there's no agreement? I mean, what's
Um, yeah, I mean, people kept asking me about that paper, and I was like I didn't want to touch it.
right?
It's such a distant data point from anything else. And, I essentially think that academics and climate scientists aren't trying to hide stuff.
No.
They can have reasonable disagreements about these things, um, but that one's just way out. At any rate, the really important thing about knowing CO2e and actually having it that value
Hmm.
is that that's all that really matters. We think CO2 matters, but no,
It's
CO2e is the
everything.
thing that matters, right? It's
Everything in
all of the
in the
greenhouse
bucket.
gases mixed together.
Oh my God, it's pouring here.
That's what matters. I'm just talking and talking here,
Yeah.
so I don't want.
No, I'm hearing the pouring rain. It is, I mean, it is torrential. And I thank God my leaking skylight has a goddamn tarp over it, or I'd be sitting here going,
Oh,
oh my
Now,
God.
and
Yeah,
I
it's
see
like,
years from 105 degrees here in Santa
yeah.
Barbara.
Oh my God. Uh, so, all right. So, in the long run, calculating all of these numbers together and putting it's all a bucket. It gives us a thought process. What is the end result that the layperson should take away from this bucket of gas?
Um, I, I, I mean, for me personally, I am so profoundly frustrated by the lack of information on this. Someone somewhere should have posted a calculation sample.
Okay.
This is how it's done, right? After
Okay.
all of these years, right? And the
Wow.
one sample we have from Glixen is just nonsense, right?
oh
As a
my God.
calculation.
Now, have you spoken to him?
No,
No, no. Okay.
but I've certainly made it abundantly clear on my blog. By the way,
Hmm.
I post all the details for anybody who wants to read all of the fine print here that
Okay.
I'm leaving out. It's on my blog, climatecasino.net, and you
I'll
can
put
read
it
it.
in the show notes for sure.
But I mean, the takeaway from this right now is that the real CO2 level, planetary CO2 equivalent, is not the Mauna Loa 424,
Hmm.
Keeling curve. The real CO2 we're at right now is somewhere between 530 and 540, somewhere in that kind of error bar range.
Well, I
You
don't
know,
think you're going to hear that on CNN.
I mean, if you want to say where are we right now,
Yeah.
and we look at 560 as doubling the temperature, right?
Right.
Then we are not going to stop short of that CO2 doubling, which means if that number's 3, we're gonna go up by 3. And if that number's Hanson's 4.8, we're gonna go up by 4.8. And that's where we are today. You know, you can live in some utopia where you say we suddenly stop emitting methane, and the Siberia and the
Stops
ESAT and
thawing.
all,
Yeah.
doesn't explode with their methane bombs, and
Oh, God.
some beautiful universe where we suddenly everything's green, and but we're almost double, so we are almost at 3. So worst case, I
Mm.
mean, best case scenario based on these numbers is about 2.7 C. I mean, that's best case
That's
scenario. That's if this doesn't
high.
grow anymore.
Oh,
You know.
yeah. But I mean, you've explained it to us. I get it. I hope
Mhm.
everybody else
So
does.
so Elliot, is it because there's a lag that we're not actually there temperature-wise? Is that what it is?
Yeah, there's certainly a lag, and I mean, you probably know or have an estimate of that. I've heard like a 20-year lag or something like
Yeah.
that
There's
between,
Yeah.
the level of
some people
CO2,
say
the temperature
five
catching.
years. 5
What do they
years.
say?
Oh, well,
Five?
there's scientists on Twitter say 5 years, 20 years. See, that's another thing. We go to net zero and we will stop. We will get, it'll be cleaned up in 5 years. I mean, I
Well,
don't know
I
how
mean,
anybody can
I want to,
definitively
but
They're
Sandy, I agree
dreaming.
with them. If
5
we were at
years?
if we were at net zero,
All right.
yeah. The problem is we're never going to get to net zero. That's a complete fallacy. Civilization will not
No.
stop burning up this planet, right? Someone asked today, when do you think the last gasoline-powered engine is going to be used? Right? It's going to be used the day before humanity goes
Oh,
extinct.
jeez.
So,
Yeah.
I mean,
Oh my God.
that's how humans are, right?
Well,
So,
we
anyway,
certainly don't see a political will to change. I mean, I see a lot of companies, though, coming up with all these technological things. I keep my finger on the pulse of technology, and there's now solar fencing that doesn't wreck your house, and there's these smaller windmills that have solar panels right on the windmill things, and they're more geared to individualized power energy for your home, which I like that idea because I would love to see it energy nationalized and taken out of the corporate private sector. And I would love to see it be individual to each home, but it's never going to happen that way either as long as we're this way, this
so
society.
why don't you put up something else for us to look at?
All
I'm getting
right, let's get the Jennifer. All right, we pulled up this.
Um, well, that's pretty cool. So this is my table that shows the monthly global surface temperature anomalies. And, the data is available from 1940 for every single day. And so you can figure out, based against the 1850 to 1900 baseline, exactly what the anomaly is for that month. And I plotted every data point. And then, some people say that temperatures are accelerating. Other people say, no, they're not.
Hmm.
But most people agree that things are accelerating.
All
And
right.
accelerating temperatures is exactly the same as having a quadratic fit to these data points. All right. Acceleration means quadratic curve. And if you look at that red line there, that curve fits so beautifully to that data, right? It just feels like it belongs to that data. It just,
Yeah.
there's nothing about that data that looks linear. I mean, this curve, and so what you see is that curve passing 1.5 in about 2027, right? When you forecast it forward. So, that's, people say we're above 1.5 today. Well, yeah, we've had a year above 1.5, but if you look back in 2016,
Mm-hmm.
right, that
Mm-hmm.
first time we crossed 1.5, you might have had the same feeling then that, oh, now we're past 1.5.
Really quickly, Jean said anomalies meaning what exactly?
It's the amount above the average temperature. So, for
Okay.
example, if you look at August 2024, what you do is you compare that to the average temperature from every August between 1850 to 1900. You do an average for all the Augusts from 1850 to 1900, and then you do the average for August of 2024, and you see how much warmer this August is than all of those
Mm-hmm.
Augusts averaged together, right? That 1850 to 1900 baseline. And that gives you that data point. So the scale along the left starts at 0 and 0.1 and 0.2, and we're past 1.5 now pretty solidly for the last 15 months or so.
Yeah, right up here. Yep. All right. Let's go and move to the next one. Jennifer, did you want to talk about this one?
No, Eliot wants to
Okay.
talk about this one. This is the map of Eliot's abode by the sea. And
Ah.
Eliot, it looks like you are having a big heat wave. Is that not right?
It is right, and it's historic. This heat is historic, but this is just one part on the planet where it's historic, right? I mean,
Yes.
uh, it's, I mean, holy crap, it's historic everywhere.
Everywhere.
Crazy, but
Everywhere.
yeah, no, it's. We were at 104 at my house yesterday, about 102 today. And who knows what it'll be tomorrow? But in the foothills around our house, it's up over 110, 115, and you go inland, and Burbank or something posted 115. I mean, these are not simply daily highs. There are places, multiple places hitting monthly highs, and there are a few places that, believe it or not, are hitting their all time record high, in this area. I
Mm.
mean, it's not July when it's hot, it's not
Mm.
August when it's hot, right? It's end of the first week of September when it should be cooling down, the days are shorter, and it's just brutal. and
And the
and
worst part is the wildlife. How are they acclimating? How is wildlife? I mean, it hurts me. It really hurts. My God, I cannot believe what I'm hearing outside. Oh my
Really
God.
boring.
I mean, pouring torrential. It never rains anymore. It torrentially rains. Just it sounds like somebody's on top of my house just dumping humongous like
Well,
cement truck full of
this is the most humidity the planet. I mean, there's tables and charts and graphs showing, like, there's it has never been this humid on average on the planet as it is now, and that's because we have 10% more water vapor, in the atmosphere now than 100 years ago. It's so, yeah, it's crazy, but um,
Matt's gonna get burned. Touch that map. Oh my God.
yeah.
It
So,
is
it
so.
rains reports, but here, you talk about the animals, and I do what I can for our
I
animals. We
know.
put out food for critters, and we have a couple skunks who like to visit us now, and
Hmm.
we don't know their names, so we just call them all Skunky.
Oh.
Um,
Hmm.
but we also feed the crows, and any critter that wants to stop by has got food here. We don't discriminate. But our owls like to eat our bunnies, so we're not a fan of that. So.
Well, what are you gonna do? What are you gonna do? And everybody this week has been talking about Phoenix.
Yeah.
And one of the things about Phoenix is they're talking about the sustained heat, and it was what 100 days, and I've been, as I've always said, I read these comment sections, and you read people saying, oh, well, I've been in Arizona for so long, and blah, blah, blah. They're trying to minimize the
Hmm.
horror of it. And it's very sad because people are saying, well, then I just have to stay in the air conditioning all the time. And I was explaining to someone, yeah, all that air conditioning is just another tipping point because the more you're inside and building with air conditioning, it's heating up the atmosphere faster, but you can't go without the air conditioning or else you're going to die because of the
Yeah.
wet bulb, which Paul Beckwith did a thing on wet bulb temperature. No, he was outside doing it. And it is quite, it's disconcerting as hell.
Yeah, and Death Valley just had something where they were saying, it's not about the hottest day, it's about how many hot days they've had. You can make it through one hot day, but when it's day after day after day, setting records,
Mm.
it's just, and, you think, well, maybe this is just an abnormal year. Maybe next year will be cooler, but no, next year's going to be hotter, right?
That's what the conventional wisdom amongst the science community is.
Yeah, I mean, it just blows me away to see that. And there's another city here, and that just made the paper. I don't remember the headline, but it had a similar record where how many days the low temperature didn't go below 90.
Yeah.
They set a record for low temperatures above 90. It's crazy hot.
Hmm.
Um,
I wish
that's
you guys could hear I wish you guys could
I
hear
can
it.
hear it.
Oh, you can hear it.
I can hear it.
all I can hear is the fan blowing on me because it's so
Oh,
hot here.
yeah.
You know.
It's
Yeah.
scary. I get
Well,
scared.
I can hear it over on your end, Sandy.
Wow, right through my mic.
Deluge, yeah.
You hear it?
Well, hopefully you won't float away. You're not in a
No.
valley area that could get
Well,
flooded.
my house is raised up, and I already had repaired my basement flooding 2 years ago. It was, and this year was the roof, and of course, they call skylights leak lights, and I have four of them. So the one was leaking right in my bathroom into the tub. It's brand new. So it'll get repaired, but at least the guy finally came and put a tarp over it so I didn't have to watch the cats trying to bat the water in the tub every time it rained, which was the whole freaking summer. I have to say, though, we did have the most spectacular, gorgeous week this whole past week. It was gorgeous. Yeah, so it was the best week of the whole summer, but, you know, it is what it is. What's it been like in Colorado, Jen?
It's been lovely here. I mean, we're over. No, it has been lately. It's just been great. We had some heat, for sure, but now it's mid 80s during the day, and I woke up this morning. It was like 55 outside, so it's
Nice,
just
nice.
lovely.
So
Yeah,
everything is going well over there for you, which
everything
makes
is
me
lovely.
happy. It's
Hey,
good.
everybody, everybody move to Colorado, quick.
No.
No, they're all coming here. All the properties, the people are
Yeah,
selling
they
it
are.
off like crazy. I'm
Yeah,
serious. I hate
yeah.
it. I don't like it, but I'm staying put. All right, let's move on and we can talk about our one of our other favorites.
So I thought that this was interesting, Elliot, because it was last year, I think in June of 2023, when you were doing all that North Atlantic temperature work. And that's, I believe, when things really started to go
Yeah.
off the rails. And then at the beginning of this year, because this is a 12-month graph, as you can see, it looked like, well, maybe we were going to reintegrate, but look now where the red line is meeting the yellow line. X marks the spot. What that means is that we are now into the lowest Antarctic sea ice extent for this time of year ever.
Yeah, so just so people understand, it's winter now, or
Mm-hmm.
just beginning of spring in Antarctica. And so sea ice has been growing for, the last 6 months there. And the maximum extent, the time of year when it hits its maximum, typically is this week or next week, right? So we should be at the maximum or very close to it that Antarctic ice is going to be this year. And last year was, if you remember the quote, was gobsmacking bananas,
Yes,
right?
yes.
And
Jennifer loves that sort of term.
in uncharted territory,
Yeah.
right?
Right.
So,
Right.
and this year we're still below. We've got So this year is about 100,000 square kilometers lower than last year still. So last year's maximum extent, this year is still not broken it, right? We still have not broken last, we're below it. And really, literally, we have about 2 more days for this year's extent to break last year's
Oh
before the
boy.
seasonal change starts driving it in the other direction, right? So, as stunned as the world was last year, and especially the climate scientists from Antarctica, right,
Mhm.
as
Mhm.
stunned as they were at what happened,
Mhm.
I mean, this year may be worse, with the minimum,
Right.
with that maximum extent hitting a new all-time low.
Right.
Um, so this is crazy. I didn't expect this to happen, right? The Climate Casino had a wager that I put up there where I just felt really comfortable. Like yeah, everybody said, "Oh no, it'll never break last year's," and then you see how much it was above it there, right, for
Right.
so long. I
I
was
don't.
like, "Oh, I'll do this easily,"
I
right?
don't think Dr. Gilbs anticipated that either. She does
Yeah,
her
no, I mean,
Antarctic.
I haven't
Oh,
seen Rob Larder. I haven't seen anybody posting about this on their
well,
YouTube.
that's yeah, maybe they should be. But I remember I had her as a guest, and she had insisted at that time we had not passed 1.1 C, and that was clearly not the case. I think
Well,
they're very conservative.
she actually was the one who inspired me to do the mathematics,
Good.
because she actually said in one of her videos that we were 1.26C
Okay.
above 1850 to 1900, quoting the Met, the UK Met number, right?
Yeah,
And I was
she's.
like, how the heck did those guys come up with that? And so I used their methodology and I came up with 1.43. So,
Oh,
Interesting. Wow.
wow.
so
Wow.
it's like, come on, guys. Um, so any rate, yeah, this is stunning to me.
It's
I
stunning.
watch this every day. This is like the biggest story on the planet right now is Antarctic sea ice
It's
extent.
tragic.
Maybe not getting up to what it last year's incredible result. I mean, just nobody would have thought that you could match that year over year. Amazing.
Mhm.
Mm.
And
Oh,
and what's also remarkable, Elliot, is last year and this year has just pulled away from the pack. It's not even two standard deviations within it. It's cutting a whole new track.
Yeah, no, it is close to three standard deviations, these current values. So yeah, these are numbers that might happen once in 100 years, but they shouldn't happen back to back years. you know, I
oh
mean,
my
it's just
gosh.
crazy what's happening down there right now, and that
It's
reflects in
frightening.
global sea ice. So the next one you're going to pull up is the global sea ice. So because Antarctic is so low, right? The only chance the globe has to make up for that is if the Arctic has a lot of sea ice, right? Because you
Yeah.
add all the sea ice together, well, that's a problem, right? Now, the Arctic isn't at an all-time low, but
No.
it's roughly fourth lowest, maybe third lowest or fifth lowest, depending on the day. But if you take, the lowest together with the fifth lowest and you add them together, and you can see we are actually, as of yesterday's data,
Mm-hmm.
at a record low for global sea ice extent. I mean, this is the blue ocean event effect, right? This sort of, the more open ocean you have, the more it heats, the less it's capable of icing over again. We're witnessing, a blue ocean event here start, unfolding on a global scale.
Although
I,
nobody wants to say it like
I
that
mean, and
right
what you
now.
just said about these lines breaking away from the pack. Look at that black line. That's the 1991 to 2020 average, right? That isn't some
Yeah.
average from 1850 to 1900, right? That's not an average from 1900 to 1950. That's the most recent average that we have.
Wow. So that's the 30-year average, that black
That,
heavy
yeah,
line.
that's the most recent 30-year average.
Wow.
It's the
So, yeah,
Antarctic that drives the ocean conveyor belt.
Well, it's that's where it starts and it goes up and through Greenland and back down. Yeah, it's a one big cycle, but it certainly goes through there. I mean,
Yeah.
that is part of it.
Wow. Well,
So I don't know. Did I don't want to step on. I know that you know a lot about this. So
No,
any what?
not at all. I completely defer to you in this
Oh, well,
regard.
yeah, we
I
do.
don't know.
I mean,
I
we
just
did.
I just love data. I don't know what it is. I'm born and raised on data.
We
So
need people that love data. We had our state of the planet 2 weeks ago, and we did go through all of this. But it's great to go through it with you. We actually would love to have you with us with a state of the planet. I'd love to have you with Antonio and Nick and Jennifer and Jim together. So maybe we'll have to plan something like that because you and Jim are data nerds for sure.
Jim Mass is great. I think the world of the man. And so yeah, anything he says about oceans, I would absolutely
Whoops.
above anything I say.
Yeah. Well, I mean, yes, everybody has their specialties, and Jim definitely is. He is the ocean guy. I can't say how much, tell everybody how much I've learned from Jim. And we always make the joke. Nobody knew what the hell a zetajule was until he came on Environmental Coffee House. We always say that to him. I thought, what's a zetajule? A necklace? So anyway, all right. Well, I think we've done. We're gonna do the questions and answers. I pulled up and I've got some things. Let's start with Jean. Jean, Elliot, is the move to La Nina cooling temperatures anywhere?
Good question. It seems to be changing a lot. There's not been a really strong signal for La Nina the way in the past there might have been for the last El Nino, where you could say definitively yes, that's going to happen. Recently, I just think in the last couple of days, there was sort of one report. Yeah, we started to see this develop, but it might start out weak. So um, what they were saying is that here in California is that we tend to get the most rains or a very rainy season when we have like this very sort of slight La Nina happening. So they're being encouraging to us that this is exactly what we need for rain. Of course, you have too much rain, Sandy. But
It's
then
not stopping.
there's this very rare La Nina happening, in the Atlantic, in the equatorial Atlantic this year, which is, I mean, it's just strange. What's going on in the oceans? The fact that where's the freaking hurricane season that everybody was
That's what
dreaming about?
has been a topic of conversation that it could sneak up at the end, who knows?
I mean, I got to tell you, CNN had me on, right? They're like, we need someone. We can't get all the top climate scientists. Let's get Eliot to talk about hurricanes. So I'm talking about hurricanes, and how we're going to have so many hurricanes, and it's going to be the worst hurricane season, and
And then
because that
look,
like, where's the hurricane?
Big blowout.
but
I
that's
think that's
scaring
really
the scientists. It's been scaring them.
It should, because we have these models that we use over and over, and they're like tested. We run 1,000 simulations to try and see how the climate will evolve over the next 6 months, and we take the sort of the main line, and the ones that are sort of off one little bit or another give us our standard deviation, our envelope, and this is essentially not in any of them, right?
Right.
This is a non-existent in the models, and the fact that is happening not just for hurricanes, but for Antarctic sea ice, for North Atlantic sea surface temperatures, right? For so many things are outside of
Right.
anything that
Right.
we
Well,
have a model for,
Can
right?
we do a little going over review for Jake, Jake is what you can do. Jake and the Letter Hack. I'm on the show Wednesday nights left past 10 with them, and we do talk progressive politics, but it's my fun night. But Jake wants to know what a blue ocean event is, and I mean I can answer it, but let's who wants to take that one?
I mean, I'm glad to talk. I'm
You're here,
You're
Eliot.
feeling
Take it
better,
away,
Elliot.
man.
Yeah.
I'm feeling better.
Good.
This is, I love your show, so thank you.
Oh, thank you.
So a blue ocean event. I believe Paul Beckwith actually came up with that
Yes, he
term.
did. I believe he did too.
And the point is that there's this ice albedo feedback loop. So as there's less and less sea ice and there's more open ocean. Well, open ocean doesn't reflect sunlight the way ice does. So it absorbs heat, and that means the ocean warms up. And when the ocean warms up, then it's harder for ice to form during the winter season, which means more ice will melt in the next year, which means there'll be more open ocean, right? To heat up. And so there's well-known feedback loop between sort of open ocean and ice. And what Paul said was that when the ice gets below the minimum extent, which happens in September, falls below 1,000,000 square kilometers in the Arctic, that will set off a tipping point that will result in no ice year round in the Arctic. So essentially, once you fall below a certain threshold of ice, that will expose so much ocean to heating during the summer
Right.
that effectively the water will be so warm that ice will not be able to form in the subsequent winter months.
Mm.
And right now, this year, where the minimum is going to be right around 4 million square kilometers. The all-time low was in 2012 at about 3.2 million
Yes,
square kilometers.
that's right.
Um, there have been predictions right, left, and sideways for when the first blue ocean event will happen. There's another famous guy on YouTube who thought it would for sure going to happen by 2016 and we would all be extinct by the end of next year. My personal over-under is 2043. I've written an article about that. You ask people in general what they think. Most people think it's going to happen in the next 5 to 10 years.
Well, we don't do it on this channel. We have no way that we would ever prognosticate any kind of number, year, anything like that. But you can because you're calculating it. It's
Well,
quite scary, though.
I actually have a wager, one of my fake wagers on a blue ocean event. And, I like to, I understand that my audience is mostly doomers and they think things are going to happen faster than I think they're going to happen.
Right.
So that allows me to make a lot of fake money. Um,
Fake money. Listen, I need real money, guys. There is something called super chat. Okay, forget it. I'm kidding. But don't be shy, guys. Help the channel. I got to do that little pitch like all the other YouTubers. Like, subscribe, help the channel. Oh, I'll read the super chats at the end. Bullshit. But anyway, I'm not that person. It's hard for
click
me.
on the like and the
Oh,
subscribe.
click on like and subscribe. Yeah, I have that graphic, but I'm not your normal YouTuber type
So,
person.
so is that roughly your understanding of a blue ocean event?
Yes.
What
Yes.
that
Yeah.
means?
No, you explained it really well.
Right.
But let's take it one step further. So once a blue ocean event it has happened, what are the downstream effects for life on Earth? Like we've lost at that point when the blue ocean event happens, we've lost our air conditioner that is the Arctic, right? What's going to happen to life on Earth after that?
Well, well, I mean, one of the things to just think about is the physics of it. So the question is, where is the cold spot then, right?
Yeah.
Once there's no ice. And the cold spot's obviously going to be Greenland, right? Because it's got ice, So the polar vortex is not going to be the North Pole. The polar vortex is going to be Greenland, right? So,
Mhm.
I don't know enough about how the climate in the jet stream to know exactly what that's going to do to where, but it's going to essentially screw everyone everywhere, right? It's going to be a lot colder than it's ever been where you live, or a lot hotter than it's ever been where you live, right? But I mean, in general, the point is, yeah, there's going to be this rapid heating of the entire planet because we no longer have that ice. We no longer have that albedo reflecting incoming solar radiation, right? So there's this thing called the Earth energy imbalance, the difference between energy in and energy out. and that is how fast, a measure of how fast the planet is heating. Right
Mm-hmm.
now, it's about 1 million Hiroshima bombs worth of heating per day. Once you lose that reflectivity in the Arctic, you have all of that heating coming in that's going to add to that pile. So, yeah, there will be accelerated heating, which is why this is a feedback loop, right? That's why this is a
Right.
tipping point, and why this is going to lead to, a whole catastrophic sequence of events. Yeah,
Mm.
um, I'm not. I don't think it's going to play out as fast as some people feel like it would play out. In 3 to 5 years, we'll all be extinct,
I
kind of.
think that's
You know,
kind of a
but
little
it's definitely
excessive.
once we hit this tipping point, yeah, it's definitely it's like the AMOC.
I
It is
was
one of
just going to put up Jason Odom. Hi, Jason. Recommended the video Maz Alone to visualize the Blue Ocean event. And then we talk about the AMOC quite a bit with Jim when he's here. We've done many shows together on the AMOC, but why don't we talk about that a little bit just to clue in some of our newbies here? Uh, let me see. I had a question, but somebody had it. I forgot where exactly it was about the AMOC, but the AMOC, Atlantic Meridional Overturning Circulation, which is responsible for. Go ahead.
Jennifer.
Oh, yeah. Well, the AMOC circulates basically, it's part of the global thermohaline ocean circulation. And without the AMOC, you don't have, um, it's not circulating, and it doesn't brush Europe, for one thing, with a brush of warm air. So Europe would get cooler, and it could be stopped by many factors, including the Greenland ice melt, which is tremendous, coming off the tip of southern Greenland there, right where the AMOC actually takes a dive from the surface and then dives down into the deep water. So the deep water formation is being slowed down, and we've already seen a marked decrease in the volume of the AMOC. So it's not
Right.
something that would happen overnight, but
No.
it is something that they've actually seen considerable slowing within the AMOC. The last time the AMOC stopped entirely, I believe, was about 14,000 years ago during the end of the last ice age, and could happen again within our lifetime, because there is such a thing as a tipping point within the AMOC circulation. And once that tipping point is hit, things happen very, very quickly, and the AMOC could shut down quite a bit very quickly. Eliot, what do you think about that? Do you think that the AMOC could shut down at some point during our lifetimes?
Well, I have grandkids who are 5 to 10 years old. So yes, during their lifetimes, pretty certain, much
That
a certainty.
hurts. Jim
Um,
always says he's very cautious with saying that the AMOC is something that's going to happen like tomorrow. We're going to have the day after tomorrow. I mean, it's such a
I agree with
process. Yeah.
I agree with that. It is a slow process. It's already been going on, documented for almost 100 years that they can trace the slowdown. It I mean, the models suggest, and I don't have the latest data, that it would require about 10x the meltwater from Greenland that we're currently seeing to effectively get that pool of cold water to just, cut out the circulation. The impacts, may happen over a period of 10, 20 years, 30 years. It's not going to happen over the course of a year or two. The best expectations are sort of mid-century that I've seen as far as some effect. But yeah, I mean, it's so funny that this is like an opposite impact to the Blue Ocean event, which will probably be happening around the same time,
Mm-hmm.
in full glory, because we should expect, you mentioned Europe cooling off.
Hmm.
Well, depending where you are in Europe, because this current, brings the warm water up and then it dives down underneath. And so the place that it sort of warms the most is the northern coast of Norway, right?
Oh,
So
yeah.
Right.
that's the part that we're expecting to cool by 10 to 15 C, maybe in Fahrenheit, maybe 20 degrees Fahrenheit, of cooling could happen there. The rest of Europe might see 3 degrees or 5 degrees of cooling. But the weird thing is, you have 3 to 5 degrees of cooling, but you might have 3 to 5 degrees of warming from the blue ocean
Mm.
event. So,
Right.
Okay.
So
you
does it kind of equal it out a little
I,
bit?
it's going to be such a chaotic, which is going to happen first, and will one affect the other, and
Yes,
are
exactly.
cascading tipping points, or so I think when we take these tipping points in isolation, you can talk about them, but the
But you
understanding that
can't.
we have multiple tipping points, sort of, working
Concurrently
together.
happening. I mean,
It's
it's
like the three body problem. What can you say?
okay. Let's see. We've got, oh my gosh, tons of questions.
Oh my.
Oh, let's see. Well, here's a comment. Looney Tunes, our moderator. Sandy, last year we were saying it's too damn hot. Now can we say where the hell are the hurricanes? Okay, Looney, honey, you can say whatever you want. I needed to bring him up. All right, and Devil's Therapist. Oh, the songwriter. He's the person I collaborated with Donald McCarthy on the Doom song. We did the dancing song, and
Oh,
he's from Germany. Dennis, I'm wondering how many years, decades we are lagging behind in regards of all the gases we have in the air now.
Well, you answered that, Jennifer, right? I mean, or you
I
guys.
mean, and it when they first started talking about it, they were saying like 20 years, and then they said 15, and then they said 10. I haven't heard less than 10, but Sandy has apparently. But basically, that's the amount of time, kind of like think of it as the momentum that's baked into the cake.
Hmm.
That's the amount of time it would take to realize what we've actually got going on, because it doesn't come to fruition all at once. So, what that means is no matter what is done from an environmental greenhouse gas perspective, there's going to be a certain amount of momentum. If it stopped dead, if everybody in humanity just stopped emitting greenhouse gases today, this train is going to keep moving down the track, and probably not just for another 20 years. There's so much other momentum baked in. It's going to take a long time to slow this thing down.
Okay, thank you. And Jackie's was, what was the CO2 equivalent in 1750? Did you evaluate that? Did you mention
Yeah,
that already?
yeah, it's 277 parts
Okay.
per million.
All right. So that was a
Because
question from a while back.
No, but that's a great question, because
Hmm.
essentially, you zero out all the other GHGs, right? So the only greenhouse gas you're concerned with is CO2, and that NOAA actually has an official value, right, of 277, not 280. They actually say 277, which I use in my spreadsheet. Um, so yeah, it's sort of like that's the only greenhouse gas that mattered in 1750. Everything else was just status quo. We added to CO2, we added to methane, we added to nitrous oxide, we later added all these halogens, right? That's what we're looking at. How much did we add of each?
Okay. All right. All right, Gary. Gary. Clarification, please. If we are nearly at CO2 doubling, does that mean we will see a 2.7 C rise actually happen within a few years' time, or a
Yeah,
decade or two? Any
yeah.
chance to reduce heating soon? Hmm.
So, I mean, that's the whole point. So we're not quite there yet, right? We're not quite at doubling, but if doubling is equal to 3C, then yes. And there's a 20-year lag, as
Yeah.
Jennifer said.
5, 10,
then
15, 20. Yeah.
then we should expect in 20 years to be at that temperature, right? So yeah, I mean, but in realistic terms, my best guess is 1.5 in 2027. 2.0 is going to happen in the mid 2030s,
Oh
and
my gosh.
2.5 will be early to mid 2040s.
I'm gonna be
So
too
that's
old for that shit.
but that's 20 years, right?
Yes.
So 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 yeah, that's completely consistent
Yeah.
with that. But along the way, those greenhouse gases, that CO2 is going to keep on going up and imply even more heating in the future after that,
Mhm.
Okay. I
which is
got
really
one.
scary. I mean, it's really that is just mind blowing.
It's mind blowing.
Yeah.
Tommyist. Oh, go ahead, Jennifer.
Oh, I was just gonna add on to that and the self-reinforcing runaway feedbacks, Elliot. So even if human beings' emissions go down, you're gonna get emissions that are coming off of the permafrost itself and other
Yes.
places as well.
Yeah,
True.
and that's a to be seen. I mean, that will continue to develop. We're not there yet. There's a lot of ongoing research. That will happen eventually. That's 100%. But that's one of those things like the AMOC or the Blue Ocean event. Like we know this will happen, but I'm still I'm still don't have the kind of date certain feeling about that I do about some of these other things,
Oh.
personally. I
Mhm.
know some people sort of peg their, like, it's already happening, we're already seeing it. Yeah, there's some methane already, certainly
Yeah, there
from
is.
gas, and there's some,
From the Pingos.
yeah, no,
The
there is some,
Pingos and
but
Jennifer and I have done shows on this for the last 5 years.
but it's not registering yet on the global isotope level.
Mhm. I
You know,
agree.
it,
Yeah.
it, it will eventually, right? There's no question about it, but not yet. And I guess you guys have a much better feeling for the timeline than I do. Then, if you've done shows on
Oh my
this,
gosh, that was one of our
Well,
big things, and we've talked. I mean, we've looked extensively over the years at the permafrost and what's coming up, and
well,
the
the first show I ever did with you was on methane because
yes,
in 2022 we had this huge methane spike, right? And
yes,
it looked like methane was going to the moon, and I was looking at methane lifetime, like what are some other reasons methane might be increasing other than emissions? And we looked at um, the radicals, the hydroxyl radicals,
uh-huh.
and the fact that there were all these fires in Central America, and how the carbon monoxide cannibalized the hydroxyl radicals. Um, so for me, I keep very close tabs on methane. It has been kind of, the rate of increase has been slowing. The rate of increase has been slowing, not the methane. The rate of increase has been
Right,
slowing for 2 years.
right.
mhm.
That's turning around now, right?
Mm.
And I'm seeing signs that methane is starting to accelerate again. And
Mm.
so you'll have me on in another show. We'll do a methane
We'll
update.
do a methane update. Okay, you mean the I have to do it again. Where is it? The methane. Yep. Okay. All right, Tommy. As for
Oh,
Elliot, how long will it take before the stressors caused by climate change climate change become large enough to destabilize global industrial civilization on a catastrophic level?
God.
Wow, that's a mouthful.
Uh-oh.
We
I
can't
mean,
prognosticate. He just said it earlier, but you know.
it just depends on where you live. I mean, this idea of global industrial civilization as being a singular thing, it
Right.
is so complicated. And, if there are parts of the world that are already in collapse, absolutely in collapse.
What
And
there's the huge drought in the African country of I forgot which country it is. I mean, these people are just they're
yeah,
just one
there's,
step away from everything going.
right. And it could happen fairly quickly. It could take a long time for, but clearly the first world countries like the United States or Europe or UK or Australia for that matter, are going to continue ripping off whatever resources we can from the rest of the world to preserve our lifestyles for as long as we can.
Mm.
And I mean, that's the name of the game we played, as exploiters of the planet, so that we could have new TV
Absolutely.
sets.
Yeah.
Um,
And we're all that here. Nobody can say that we're not part of it. No matter what we do, we are in this society we live in. We all are living it. No, and we can all do wonderful things, and I do them rewild and whatever. But I'm still getting an Amazon package for cat litter. But I do my cost benefit, and I say, okay, they're out anyway driving. I don't have to leave the house. They're going to be out anyway. I don't have to use gas or whatever. But that's just a rationalization because that's what we do. We're good at that, right?
So, I have a number of wagers on the climate casino that have to do with the collapse of global industrial civilization. And, one of the wagers is, for example, whether the 2026 World Cup will happen or not.
Oh,
So you can pick on little specific
no,
things
they kidding.
and try and identify collapse with some metric. And so, I do that and I set lines that I think I'm going to win because I think people think it's going to happen faster than it is
Right.
because we really genuinely are. I love this cat. Jennifer's holding a cat.
Yeah, it's her little kitty. Yes, we love the
Oh,
kitties.
I wish my cat was in here. We could be dueling cats.
I absolutely do not wish any of my cats were in here. It would
I'm
just
a
be
childless.
you're a childless cat lady, and I'm a grandchildless cat lady. Okay, let's see what else do we have.
One more, Sandy, and I'm going to
Yes.
have to call it.
All right,
I'm
sweetheart. Let me see if I can find. There was one more, I think, from someone who has not had something up. Uh, okay. Singing way. At what air pressure altitude are your CO2 numbers? In my kitchen right now, my CO2 ppm monitor says 465. Oh, look at that. Okay. Jennifer, we can't hear you.
so
Sorry.
yeah. Okay,
The
about
cat
four.
muted her. The cat muted her. Oh my goodness. Hopefully we can hear you. Well, we're almost over, but we want to hear you. I didn't mute you. You're not muted. I don't think you're
Can you hear
muted.
me now?
Yes, we can hear you now. What would the
Ooh,
show be like without
it
one thing?
it got
Yeah.
it got stamped on.
All right. We have to do the flush of the day before Elliot leaves.
Oh yeah,
So
totally.
since Elliot, you are the guest of honor, what do you want to flush away?
Um, all the trolls on Twitter.
Oh, let's do it. Let's do it. Goodbye, trolls. Bye-bye.
Hi trolls.
Bye-bye, trolls. All right. Yes, that was a perfect way to end by saying goodbye to the trolls on Twitter. Although hopefully we'll move to Blue Sky soon and get rid of Elon Musk. So I'm
Oh,
sorry if I
oh,
didn't get to
so
get
yeah.
all the questions. Elliot's got to go. It has been an hour and 15 minutes. Jennifer, let's give you two an opportunity to end the show.
All right. Well, Elliot, it has been, of course, an immense pleasure to have you here again here today. And thanks for taking us through the equivalency. That was so interesting to find out that that number basically wasn't based on too much, and you busted it out. So I hope it gets a little bit cooler. How long's the heat wave expected to last for
They
you?
just extended it another day.
Oh
So
no. Oh
I know.
gosh.
So Monday or Tuesday, yeah. So
Yeah.
the weekend's going to be 100 to 110 both days here on the coast in beautiful Santa Barbara. So
Yeah.
yeah, at least 2 more days.
Wow.
Oh, all
All
right.
right. Well, everybody, thank you for coming. We love you all, and it really I enjoyed this immensely, and of course I always learn, you know. I'm forced to learn. I'm forced to learn. But this is great. So we will be back Tuesday night for me and Elliot, feel better. Jennifer, I love you.
Love you
Everybody,
too.
everybody, we end with because this is really what we want is peace. Yes.